Hi, welcome to this lesson on number patterns arithmetic series. In this lesson, we're going to be looking at the special property of an arithmetic series. So, we can deduce the nth term of an arithmetic sequence by using the terms of an arithmetic series. Okay, so the arithmetic sequence, we know t sub n equals a plus n minus 1 times the common difference d, where n is a natural number. We also know the general term of the series of the first n terms of an arithmetic sequence, and I'll use the first formula, which is the most general. That's n over 2 times 2a plus n minus 1 times d, where n is a natural number. Okay. So those are the two formulae for an arithmetic sequence and an arithmetic series. This is the sequence and this is the series. So how can I deduce the nth term, so t1 or t2 or t3, from knowing s1 or s2 or s3? Well, let's have a look at the following pattern. If I just look at the first term by itself, that is the same as the first sum. Because the first sum is just saying add up the first term. Well, if you're adding up the first term, it's just the first term itself. So let's have a look at an example as we're going through this. I'm just going to give a generic arithmetic sequence by this formula here. 3 plus n minus 1 times 2, where n is a natural number. So if we write this list out, okay, so it's the sequence. So if I put n equals 1, I'm just left with 3. And the common difference is 2, so I'm just adding 2 the whole times. So it looks something like this. Okay. Sn, what does that sequence look like? Well, now remember, so this is T1, T2, T3, T4, T5, so on. What does the Sn sequence look like? Well, it's a series rather, but we can list out S1 is just the sum of the first term, so it's just 3 by itself. S2 is the sum of the first two terms, T1 plus T2. So 3 plus 5, which is 8. What about S3? Well, that's T1 plus T2 plus T3. So that's 3 plus 5 plus 7, which is 8 plus 7, which is 15. Same thing if I do S4. That's the sum of the first four terms, T1 plus T2 plus T3 plus T4. That's going to give you 3 plus 5 plus 7 plus 9. That's going to give you 24. And so on. So this is the arithmetic series at each nth position. The sum of the first term is just itself, T1. The sum of the first two terms is T1 plus T2. And that's exactly what I've written here. But we want to try to get the Tn term in terms of just the S terms, the series. So what I'm going to do here is I'm going to take T2 and make it the subject of the formula. So I'm going to say S2 minus T1. But T1 is S1. That we already established. The sum of the first term is just the first term itself. So I can rewrite T2 as S2 minus S1. So the second term is the sum of the first two terms minus the sum of the first term. Let's see how that works in this example here. T2 is 5. And if I do S2 minus S1, that's 8 minus 3. Those are equal. 8 minus 3 is 5. What about S3? Well, that's T1 plus T2 plus T3. But we know that T1 plus T2 is S2. Okay, so to get this T3 by itself, I subtract both sides by S2. Therefore, I get T3 equals S3 minus S2. And again, we can check that out. T3 is 7. And S3, which is 15, minus S2, which is 8. 15 minus 8 is 7. So that works. And you can keep following this pattern. T4 is S4 minus S3. All the way up to S or Tn. Tn is just going to be the sum of the nth term minus the sum of the previous term, n minus 1. So where there was a 2 here, it was S2 minus S1. When it was 3 here, it was S3 minus S2. When there was a 4, it was S4 minus S3. So at Tn, it's Sn minus Sn minus 1. So in general, if you want to find the nth term of an arithmetic sequence and we know what the series formula is. So if you're given a formula for the series, then you can use this formula here to work out in term, if you don't know what the general term of the arithmetic sequence is, but you know what the series formula is. I've written it like this: Tn equals Sn minus 1. Just noting that this really starts at 2, and we note that when n equals 1, it's just T1 equals S1. So the sum of the first term is just the first term itself, T1. Okay, so we can use that knowledge if we know what the series formula is only, and we don't know what the arithmetic sequence looks like, and we can deduce the nth term of the arithmetic sequence by just using this relationship here that we've derived. Okay, so that's a special property of an arithmetic series, and that might be used in any kind of question that where you're just given the arithmetic series formula only, and you want to figure out the nth term of the arithmetic sequence itself. Okay, I'll see you in the next one.